Alright guys, so we're just jumping in. We're going to solve some equations first, and then again, hopefully get to the half-life stuff. We don't have a lot of time left. Alright guys, so the first one here, you're given 4 to the x plus 2 equals 3 to the 2 minus x. So guys, if you just look at that, there's not a way to make the 3 and the 4 the same base, right? So if we didn't have logs, you would not be able to solve this equation other than graphically. We need logarithms so that we can solve equations where the variable is in the exponent, okay? The way you're going to go about doing this is take the natural log of both sides of your equation. It's like an operation, you know, you can multiply both sides. You can take the log or natural log. I usually do natural log just because it's one less letter, so it doesn't matter though, you can do either one. So I've got natural log of 4 to the x plus 2 equals natural log of 3 to the 2 minus x. And then guys, using your properties of logs, where do those exponents go? On the front. And guys, put it in parentheses, so it's x plus 2, natural log of 4, and then over here, 2 minus x times natural log of 3. And then you can distribute, so you have x natural log of 4 plus 2 natural log of 4 plus 2 natural log of 3 minus x natural log of 3. This is where you have to remind yourself what variable you're solving for here. So we're solving for x, right? So I would get everything with an x on one side. So I'm going to leave my x natural log of 4 over here. But I'm going to bring over that x natural log of 3. So I'm going to do plus x natural log of 3. And then on the other side, I'll leave 2 natural log of 3 alone and subtract 2 natural log of 4. Y? Okay, what variable are we solving for? X. So I want everything with an x on one side and everything without an x on the other side. Okay. Because now what can I do on the left? Factor out an x, right? So we're almost there. So I can divide by my natural log of 4 plus natural log of 3. Let's do a little simplifying on the other side first. What do those coefficients actually mean? Yeah, so this is really natural log of 9 minus natural log of 16. Do you agree with that? All over natural log of 4 plus natural log of 3. I am completely fine with that answer. If you simplified more, you could tell me natural log of 9 over 16 over the natural log of 12. You guys see the condensing there? Okay, that's also correct. So either of those work. Be aware of those options for condensing and expanding, things like that, when you get to multiple choice type questions. Okay, because the first answer we come to might not be there. So then you've got to be able to look at it and see, okay, well, what else could I do? Right? A lot of algebra, but not too bad. Or was that not good? That face.
So now you make it.
Oh no! No, there's just different ways you can solve log and exponential equations. So we'll just go through some. That one's probably the messiest of all. Alright, so I've got log of x plus log of x minus 3 equals the log of 28. So I've got a whole bunch of logs going on here, so I definitely don't want to like take the log of both sides because that's just going to confuse things. Can I condense on the left? So I've got the log of x times x minus 3 equals the log of 28. Now you don't have to show this next step, but this is why what we can do after it works. Guys, on the left, isn't that really 10 to the, well, it's 10 to the variable equals that. We don't even need to do that. You guys see how you have a log on both sides with the same base? So what do you think I can do? And you aren't like canceling out the log. You're not like dividing by log, but this x times x minus 3 is going to have to equal 28. Okay, because they're both log base 10. If they had different bases, that would not be true. But since they have the same base, it is. So then I've got x squared minus 3x, and I'm going to go ahead and bring over my 28 equals 0. How do you want to solve that? What? Just leave it. It's good enough. We're good. Yeah, let's factor it. This one factors. So x minus 7 and x plus 4. Okay. So that means x equals 7 or negative 4. Do they both work? Probably not. Not the negative 4. So guys, if you go back to your original equation and I try to plug it in like right here, log of negative 4. Think about your log graph. Doesn't it have a vertical asymptote like right there and then goes like this? So can I put in negative 4? No. Okay, so that one does not work. And now it's not just a negative number won't work, it's when you plug it in and you're taking the log of a negative number that it won't work. Okay? Does that make sense? Because there may be times where a negative's okay if plugging it in makes it not negative.
So the answer of the
I would just tell me like x equals 7. Show the work that you didn't accept negative 4 as a solution. You don't have to separately tell me though like negative 4 is an extraneous solution. I may ask you about extraneous solutions, but if I don't, you can just tell me x equals 7.
I want to go off topic, but could you give an example of an equation where you plug in a negative number
And it works. So like what if it was log of x plus 5, and now this is not necessarily one that's going to work, and that. And let's say one of my x's was negative 4. Do you see how that would work? Okay. That's not off topic.
So you can't have the log of like a negative number?
Nope. You cannot take the log of a negative number, and you can't have a negative base. She's just reiterating.
Yeah, I just want to be 100%.
She likes to say yeah. Makes sense.
Yeah.
Alright guys, let's do another one. So we've got e to the 2x plus e to the x minus 12 equals 0. That's nice. Guys, we can actually factor this. And if the like having an e in there with these weird exponents is throwing you off, we're going to do a little substitution. We are going to let u equal e to the x. We use u a lot because in calculus you'll do all sorts of u substitutions. So we start practicing now by using u, okay? So it's easy. The middle term is just going to be u. The 12 is still a 12. What's that first term going to be? U squared. Okay. Now, does that equation look a little easier? No. Can't you factor that?
Yeah.
Okay, so u plus 4, u minus 3 plus u. So I get u equals negative 4 and u equals 3. Do you think I'm done there?
Because then you have to do e back.
Yeah, because we weren't solving for u, we're solving for x. So now you've got to go back and use this. U is e to the x. So I really have e to the x equals negative 4 and e to the x equals 3. We'll stop there for a second, make sure everybody's caught up with me. Whoa. All right, everybody with me here? Okay, what do you want to do? X equals natural log of negative 4, yes. So the way she did that, guys, she's absolutely right. We're going to take the natural log of both sides of our equation. And I'll do that here. And guys, this one you do want to absolutely do natural log. Why do you think natural log matters in this one? We got an E, yeah, it's going to make things much nicer. So then when I bring the exponent in front, I've got x natural log of e equals the natural log of negative 4, and I have x natural log of e equals the natural log of 3. What is the natural log of e? 1, right? Guys, that's one you gotta know, okay? So that makes this just x equals natural log of negative 4, and x equals natural log of 3. Are both of those okay? No. Which one's not okay? That's not good. No, just the negative 4. You cannot take the natural log of a negative number. So all of that to get your one answer of the natural log of 3. Right, I'm showing you why it works. It doesn't cancel, it just is 1. Okay. And you need to understand that, like, you don't want to leave it, like, you don't want to say, well, this is 1 to the x thing, because that doesn't make sense. Like, you have to think about the exponent coming in front first before you do. Yeah? Yes. Yeah, you can never take a log of a negative. Just think again, the graph. Vertical asymptote right there, and it goes this way. So, like, none of these work. No negatives. All right. So, guys, that's the basics of solving. Now we're going to look at some half-life and such. So we might I'm not going to write out. These are basically going to be word problems. I'm not going to write all of the words for you here. I'm just going to give you the abbreviated version. So the half-life of whatever our substance is 704 million years. That's a long time. Start with 200, let's say milligrams. We'll just say grams. That's easier. How many grams after 1 million years? Okay. All right, let me walk you through the first one here. So that is a formula for exponential growth or decay. A sub 0, that just means your initial amount. So like the amount you end up with is equal to the initial amount times e to the kt. K is sort of like your river, but we have to find it. Because they don't just give you a river.
You did say indicated like
0.5% a year that that is. Yeah. Alright guys, so the first thing you have to do in any half-life, doubling, any problem like that is find the value of K. So if I start with 200 grams of this substance, and I don't know K, but I'm going to say, let's look at it after 704 million years. How much is going to be left of my substance after 100 grams, right? Half of it? You with me there? No. Do you have a question, or was that just like a little brain explosion?
Wait, why would you only put 704? Because our thing is in 100.
We are not dealing with this yet. We are finding K first. You have to know K before you can figure out how many grams are left after a million years. We know that after 704 million years, half of whatever we started with is gone. So like if I had put 1,000 right here, what would be over here? Yes. So it doesn't matter, because let's look at our very first step of solving this. What's the first thing you would do to solve this? Wouldn't you divide by 200? And what's 100 over 200? 1/2. Guys, you can start all of these. I would recommend you pay attention, okay? You can start every problem right at that step if you want to. If you know it's a half-life, you know it's going to get cut in half, that's what we're looking at solving. Okay? We're not going to square root E. What are we going to do to solve this? Natural log of both sides, right? And I'm going to just jump a step here, right? Everyone understands that 704K is going to become your coefficient. And what is the natural log of E? 1. So if I'm solving for K, are you guys okay with it being natural log of 1/2 over 704? Algebra, you with me or not?
Oh, yeah, I get it. I got it though.
Yeah? You see it? True?
Yeah, I got it.
Okay. Visual lesson? All right.
We're getting done here.
We are not done. So, that is our K, but now we're going to come over here and actually figure out how many grams are going to be left after 1 million years. So we need to figure out the amount. We started with 200. E to this lovely.
Yeah, I think it's 4 minutes.
That's
We
okay.
just put it in the calculator.
If it's on a calculator part, you could key that in and then store the value, but you'd absolutely have to store the value.
Yeah.
Yes. Okay. And then times 1, because this is 1 million.
Oh.
If it was a non-calculator question, you would set it up to this point and be done. Calculator question, you would key all of that in and get an answer of how many grams are left. I don't have a calculator up here with me, so anybody have their calculator up? Well, because we did 704 for 704 million years.
So when
So.
your answer was your right.
No, because we're just looking at grams left, so it's the
Yeah.
same proportion, so it's okay.
Maybe I just said ratio.
Yeah. You should be getting like 199.8 grams. Well, we still have 4 minutes. We can do one more of these. Michael?
So what's keeping me from doing 200 times 1/2 to the 1 divided by 704? X divided by 704 is the exponent.
So, it's good for you to understand how to solve this in terms of half-life, because it may not always be as happy as a half. Like, I may give you other things that are different proportions. Okay? Alright, let's do one more. Everyone okay with that one? Okay. So, next one, so what am I on, 5? So, you have a certain plant. It doubles every 12 days. You start with 46 plants. You're gonna have plants everywhere. How many plants will you have? I know. Again, I'm not writing all the words for you. After 20 days. So, your initial equation here, we have 46 plants. How many would we have after 12 days? No. We start with 46 plants. 92. So the way you would start to solve for K is that. Again, if you want to start at the next step, because you understand that when I divide by 46, I'm going to be left with 2 equals e to the 12k. Does not look like 12. I'm fine with you starting there. And what's going to happen when I take the natural log of both sides? Like, you can show me that if you just go to 12k, I know that you know what's going on. So natural log of 2 over 12, that's your k in this problem. It's 12k because it doubles every 12 days. You gotta find k first, okay? You do not use this until you found k. Alright, so if you're looking to solve after 20 days, your amount of plants equals 46 e to the, this lovely k of natural log of 2 over 12 times 20. Do you think it's going to be more than 92? Yes, okay. Not quite 184 though, right? So when you're doing these, make sure your answer at the end makes sense. Like you should have a reasonable idea of where you are. Okay, we have like 1 minute left. On your assignment sheet. Nope, it's next class that I'm crossing something out, sorry. So guys, that homework, page 196, that'll be due next time. Okay. Alright. We made it barely.